Good morning. Today we are going to actually continue with our targets for systems of equations and inequalities for Unit 1. And our second target is 1.2. I can solve 2 by 2 systems of equations using substitution. So just a few examples where you would substitute something in real life. If you needed to break a $100 bill, what options do you have with smaller bills? For example, you could substitute 5 $20 bills and still have $100. You could also use 20s, 10s, 5s, and singles and mix all of those together to still get $100. So you're still substituting. When cooking, if the recipe calls for butter, what is a healthier option for you to use instead? You could substitute margarine. Or when teachers are sick or have a conference for the day, the person who takes their place is a substitute. So just different places where that shows up in real life. Let's go ahead and talk about some vocab. Only thing you need to know today is substitution is an algebraic method to solve a system of linear equations in which you solve one equation for one variable and then substitute it into the other equation. And this will help you find your solution for your system. Solving systems using substitution. First, I would determine the isolated variable whose coefficient is 1. If this doesn't exist, you're going to solve or rearrange one equation for a variable. Okay, and this step makes more sense when you actually see it. So give me a second to get there. Go ahead and fill in your blanks. Okay. Step 2 is substitute or replace the expression equal to the isolated variable into the same variable of the other equation in the system. Step 3 is to solve the new equation for the first solution. Step 4 is to substitute the solution into one of the original equations for the second solution, and then write the solution as an ordered pair. And finally, check the solution for all equations in the system. It needs to work for everything. Okay? We're going to do 4 problems together. You have 2 problems to do on your own, and then you can work on your independent practice. So let's get down to it. Okay, so 2 examples here on this first slide. The first example has x equals y minus 2, and the second one is x plus y equals 8. Notice that this variable is by itself. Since x is alone, that means I can replace the x in the other equation with the second part of the equation. So since it's x equals y minus 2, I can take that y minus 2 and plug it in. So I'm going to have parentheses y minus 2 plus y equals 8. And I technically don't need the parentheses there in this problem because there's not a coefficient, but I would need them if there's a number up front, so I could actually distribute. From here, we just got rid of the x in the second equation, so that makes it easier to solve. We can combine our like terms. So y plus y is 2y, minus 2 equals 8, and then keep going to finish up the problem. So we're going to solve. Add 2 to both sides to get 10, and then divide by 2 on both sides to get 5. Okay, so substitute one equation into the other to help you solve for one of the variables. Now, if you think back to our lesson on Friday, you will remember that we were solving by graphing. We had to have a point where they cross, and I talked about how important it is to have parentheses around your ordered pair. We only have one part of our solution here. We need to find the other part. So we're going to take this part and plug it in. So I'm going to take this and plug it in to one of these 2 equations up here. So if y is 5, I'm going to put that y, or that 5, in place of the y on the top. And you could use the other equation if you want. It's completely up to you. It doesn't really matter because it has to work on both of them. So x equals 5 minus 2. Well, 5 minus 2 is 3. So our ordered pair is 3, 5. Now, to check this, we're going to plug it back in to make sure it works in each of those. I'm going to do this off to the side here. So I have 5 equals, I switched that, 3 equals 5 minus 2. Which if I do 5 minus 2, it works. And I also have 3 plus 5 equals 8, which is also working. Okay, so my check step is here. You do not have to show that on your paper. you can simply do that in your calculator and just make sure it works for both. Okay. Example 2. Notice in this problem, I don't have anything that's by itself, so like the x equals, but I do notice that this y doesn't have a coefficient. So I think I'm going to solve for that by moving my 2x over. So I'm going to do plus 2x on both sides. And I'm going to rewrite this. So my original problem was 3x plus 2y equals 26. And then I changed the second equation to be y equals 2x minus 1. So once I have that alone, or set up so the y is alone, I can go ahead and do everything that I did in the previous problem. So this time, notice that it's a y by itself, so I'm going to plug what I have into the y in the first equation. So I'm going to go ahead and take my 2x minus 1, plug it in for y. So we have 3x plus 2, and instead of y, we have 2x minus 1 equals 26. We're going to distribute and solve. So 2 times 2x is 4x, 2 times negative 1 is negative 2, and then we're going to go from there. So like terms give me 7x, add 2 to both sides, and divide by 7 on both sides. So I get x equals 4. I don't want to circle that yet. Okay, once I have finished that first part, I need to take the x equals 4 and plug it back in. So I'm going to go ahead and take this and plug it into either here or here. It doesn't matter which one, but go to the original and see what you get for y. So I'm going to change my pen color here. So I'm going to do 3 times 4 plus 2y equals 26. 3 times 4 is 12. Subtract 12 from both sides, we get 2y equals 14, and divide by 2 to get y equals 7. So our final answer is going to be the ordered pair 4, 7. And I will let you check that one on your own so that we can move on to the last two that we are going to do together. If you ever have any questions or I'm going too fast, just hit pause, rewind, raise your hand, ask a question. We can help you out. Okay, last two that we're going to do together. In number 3, again, notice that there is not an x or y alone, but there is a y right here that we could easily solve for. So I'm going to go ahead and do that first. So what I'm going to do is I'm going to do minus 2x on both sides. So I really have y equals 8 minus 2x, or negative 2x plus 8, and then this equation stays the same. So I can go ahead and plug into y. So I'm going to go ahead and take this whole thing, plug it in there. So I have 6x plus 3 times negative 2x plus 8 equals negative 15. Distribute. And then when I go to combine my like terms, this one is actually a special case, which is what it talks about up here. Dependent and inconsistent. When I combine my like terms, 6x minus 6x actually cancels out. So I'm left with 24 equals negative 15. Now, is it possible for 24 to be a negative 15? No. So since that's not possible means no solution. And you don't have to go any further there. Okay. And then the last one, notice that this y is by itself, so I can plug into the y in the first equation. So I have 56x plus 8 times negative 7x minus 4 equals negative 32. And then solve it. Distribute. So 56x minus 56x minus 32 equals negative 32. We're going to combine our like terms together, so those cancel. So I'm left with this. Okay. In the first one we did, that's not possible. Second one that we did, that is true. So negative 32 equals negative 32. That's always true. This is those dependent people that where one goes, the other one goes. So we have infinite solutions. Okay, that is it for the lesson today. There are 2 more problems for you to try. I'm going to go ahead and give you the answers to those so you can check them. The first one you should get 0, -5. The second one you should get -1, 3 for final answer. When you finish those, work them out with a partner, get your independent practice out, go ahead and get started. And we will go through these in class to make sure you're okay with them a little bit tomorrow before talking about elimination. Again, if you have any questions, rewind the video, hit pause, raise your hand, ask any questions you need to. Otherwise, if you're good, have a great day.